Right. So we are getting into switching. Switching is nothing but traffic moving between the devices that are in same network. So router won't come into picture now. All the router related topics are over. Now we are in switching. Packet moving from one device to another that are in same same LAN communication, same LAN devices communicate using MAC address. Though IP address is involved, routers are not involved. Switches are involved. Switch uses MAC address to decide on the destination. So same LAN devices communicate via using switch. Now about the switch, in the beginning days of our training, we learned that switches are intelligent device. For example, when we have some ports, connected to devices, let me call this device as A, B, C, D and E, and the IP address on these devices are 10.0.1.2.3.4 and .5. So we have 5 computers connected using a switch, and all the devices are in same network. What is the network? 10 network. 10 network. All these 5 devices are in the network 10.0.0.0 network. In that, this A computer is identified with .1, B is .2, C is .3, 4 and 5. Now, let us take the small a as MAC address of these devices, MAC addresses. Can anyone tell me the size of the MAC address, the original MAC address? What is the size of the original MAC address, the real MAC address? Very good, 48-bit size. But I cannot write that 48-bit size, so I simply make it as A, B, C, D and E. Assume these are MAC addresses of this device. You see, the switches has a memory location where the MAC addresses will be learned and stored. We call that location as CAM table or MAC address table. CAM, C-A-M, CAM table, content accessible memory, or MAC address table, MAC, MAC table. In this, the MAC addresses will be learned and stored. But in the beginning, the MAC address table is going to be empty. Let's say the port number of this port is F0/1. This is F0/2, F0/3, F0/4, F0/5. Now, when A communicates to, let's say, E, A is communicating to E. Source MAC address is A. Destination MAC address is E. When this packet arrives, switch will learn A as a MAC address on F0/1. Now it wants to send the packet to E, but there is no entry for E. So what the switch will do, whenever the destination is unknown, switches will flood the packet to all the ports on the switch. So this packet is now going to be flooded. You know what is flooded, right? It will go everywhere, wherever the space is. That is flooding. So you need to understand this very well, because this will be an interview question. Whenever the destination is unknown to a switch, and if switch wants to forward the packet, it will forward to every port except the port on which the packet entered. Except the port on which the packet entered, this packet will be flooded. It will be sent. Now when this packet goes to port number F02, when it goes via port number F02, because the destination address is not matching, it will be ignored by the computer D. Even this is also going to ignore because it's not matching. This will also ignore. So this is the only computer which is on F04. The only computer that is on F04 will respond. This is the only port that will respond. Right, so when it responds, what will be the source now? E is responding. What will be the source? E. To whom it is responding? To A. So now when this packet enters this port, switch again learns that E is the device connected on F04. Likewise, when the other devices communicate, all the MAC addresses, connected device MAC addresses will be learned. For example, here it's going to be F02 for D. For B, F03, and for C, F05. You see, this is how the MAC table get updated. As the traffic enters, from the traffic the source address will be copied into the MAC table. Did everyone get what I said?
Yes, sir.
Yes, sir.
Alright. So MAC addresses are dynamically learned as the frame enters into the switch port. The source address of the frame is copied with a port number, with a port name like F04E, F03B. This is dynamically learned. Now from now on there won't be flooding, because for all the connected devices there is a port mapped to it. For all the MAC address you have the port mapped to it. So now if D is talking to C, source is D, destination is D, the packet enters this port F02, MAC address is already learned, now it wants to go to C, it will check C, here is C, so now the packet will be forwarded to this port only, no flooding. This is proper forwarding. No flooding, it is forwarding. You see, this is how the MAC addresses and the MAC tables are involved, used. This is how the MAC tables are contributing in switching. Okay, now let us consider that our switch has got, let's say you got a very big switch. I would like to say a 96 port switch. I have a switch with lots of ports. How many? 96 ports, which means I can connect 96 devices. Okay, so we got 96 port switch, so I can connect 96 devices to the switch. Let me call this switch as switch 1. And in our office, let us say we got 50 employees only. Only 50 employees. And I got 5 departments. So what we do subnetting. For 5 department, let's say 10.32.0.0/13. No, sorry, 11. 10.64.0.0/11. 10.96.0.0/11. 10.128.0.0/11. 10.160.0.0/11. 10.192.0.0/11. It goes like that, subnetting, but I'm interested only in the first 5. This is for the first department, second department, yeah. See, we do subnetting so that we can keep the departments separate. Yeah. We want to keep the departments separate. But the problem is, let's assume this is first department 10001 and this is department 4 10.96.0.1. Will they be able to talk? Answer someone. Will these two computers, will they talk or not? There is no router here. Will they be able to talk? These are different networks. Will they be able to talk? Why no answer? See, they are in
Because
same
no.
switch. I agree, but they are not in same network. You see, when you go to this computer and say ping 10.0.0.1, this computer will not send a packet out. It won't send. Why? This, if it is 11 subnet mask, this is different network, this is different network. It knows. When it is different network, it needs gateway. What is gateway? Router's address. Is there any router? No. So will there be any gateway configured by you? No. Then how the packet will go out, first of all? Packet will not be even sent out of the PC. PC don't know where to send because you are trying to talk to different network. Did you understand?
Yes, sir, correct. Got it.
So the packet won't even go. That is the reason why you subnetted in first place. In first place, why did you subnet? You want to have security. You don't want these department guys to talk to these department. That's why you put in different network. If they can talk, then why you want to put in different network? You no need to do subnetting. In order to keep them separate, you did subnetting. That is good, you did subnetting to keep them separate. So they will not be able to talk unless you connect a router. They won't be able to talk because there is no router. But what if this guy is little rogue? IT industry will call him smart. I hate the word. They want to call thieves as smart. The real smart as dumb. That is world. Real smart people are not identified as smart. They are called as dumb people. Bible says you will be called as Paityakaran. The real smart people will be called as lunatics. That is happening actually. So thieves and all they will call smart. Now coming to the point. What if this guy is a rogue, a thief? What he does, to talk to the department 1, he simply changes his IP address. That's all. Now this is also 10.0. This is also 10.0. Now he will be able to talk. No one can stop him now. Switch cannot stop him. Because switches don't care about the IP address. They focus only on MAC address. If this PC will send the packet, switch will forward the packet. PC is sending the packet because you are pinging from 10.00.11 to 10.00.1. It's the same network, so it will forward. But in reality, this guy is not of same network. He is a rogue. He is a thief. He belonged to 96 network. But because he is rogue, he knows how to trick. He simply went and put 0 here and 11 in his computer so that he can become the part of first department. Till 10.31 is first department, 10.32 is second department. See? Even if he put 10.19 here, 19 here, 10.19.0.0.1, still, he can ping department 1. Because he is rogue, he is doing that. But he is identified as smart in this world. He is rogue. Now, How do we avoid this? Even if he changes the IP address to match with the department 1, he should not be allowed. Can we achieve this? Yes, you can. How? Sorry, 96. He originally belonged to 10.96. He originally belonged to department 4. But if he tries to change his IP address to communicate to department 1, he should be stopped. How is that possible? It is very simple. By logically grouping the ports. For example, these 4 ports for department 1. These 3 ports, let's say I want to give for department 3 or department 4. These 4 ports I want to give to department 2. And these 2 ports I want to give to department 3. This port and this 4 port I want to give to department 5. And this also I want to give to department 3. So logically I am creating 5 switches. Inside one physical switch, I am creating 5 logical switches. I am grouping the port. By default, all the port belong to one VLAN. We call it as default VLAN. I remember I was teaching you these things in the beginning. I'm repeating that. We are going more deeper now. By default, all the ports of the switch will be a member of single broadcast domain. But by creating more VLANs, we create more broadcast domain. VLANs are nothing but logical switches. Now, how many switches I have? 6 switches. One is VLAN 1. And for department 1, I am giving VLAN number. Department 1 ports, I am giving VLAN number 10. For department 2, I am giving VLAN number 20. 3, VLAN number 30. 4, VLAN number 40. 5, VLAN number 50. Yeah, I'm going to create virtual LAN. By default, all the port belong to one LAN. When it is only one LAN, this guy, this rogue was able to change and communicate to my department 1. Change his IP address to communicate to my department 1. But when I put the departments in different VLAN, it is as equal as buying 5 physical switch and putting 5 department in 5 separate physical switch. It's as equal as that. Even though he is now trying to change his IP address to 19, he will not be able to communicate because department 4 is in VLAN 40. This 19 is in VLAN 10. Department 1 is in VLAN 10. The 19 belongs to VLAN 10. But this fellow is not connected to that group. He is connected to department 4 group. Will he be able to communicate? No. Logically they are separated, they are isolated, they are divided. You see? VLANs create logical separation. With the help of VLANs, we create many switches, virtual switches inside that physical switch. How wonderful it is. You don't need to buy now 5 switches to keep this department separate. One switch. Now I'm going to demonstrate this. Sorry. We have a switch and we got the switch connected to 2 ports, and these 2 ports, and not only these 2 ports, all the other ports are member of same VLAN. And if you check the MAC table now, show MAC address table, it is empty. I told you MAC address will be dynamically learned. Now what I'll do is I'll try giving this IP address to this PC. 10.0.0.1.255.255.0.0. See, there is no gateway. We are not going to give gateway because we are not going to have routers. We are learning switching. IP config. You see, this is the address. We don't have router. Now I'm going to assign IP address to the other PC. 10.0.2.255.255.0.0. You can see here. Now, will I be able to ping? Yes, because they both the ports belong to same VLAN. I showed you, both belong to same VLAN. VLAN 1. Now, if I ping, definitely it will ping. 10.0.0.1. I'm pinging from 10.0.0.2. It pings. The reason is they are in same group. Okay, but when I put them in different wheel and see what happens, they will not be able to ping. So what I'm going to do is I'm going to take this port and assign the port to the as a member of VLAN 10, and take this port and assign it as a member of VLAN 20. Let us create first VLAN. This is how we create VLAN. Hey, let me give a name. Host name, I would like to call it a switch A. Now create VLAN. VLAN 10. Optionally you can give a name, but it is good practice to give name in production, like HR department VLAN, sales department VLAN, something like that. I'm going to simply say department 1, and I'm going to create another VLAN name department 2. Now I have just created VLAN. See, show VLAN brief. I just created 2 VLAN, but there is no ports assigned. It's empty. There is no ports assigned. Now I'm going to take this port, give it to this guy, and take this port, give it to the next guy. How do we do that? Go to the interface F0/1, switch port access VLAN 10. That's it. We have made this port as a member of this VLAN. Likewise, interface F02. Hey, one more thing. You don't need to type no shutdown for switch ports. By default, they are not shut down. So you don't need to type no shutdown. Only on the routers, the ports are in a shutdown state. We need to say no shutdown. Okay, now switch port access VLAN 20. Done. Now let us go and verify this. Show VLAN brief. Look at this. Those F01, F02 is missing here because it has come down here. Now they belong to different broadcast domain. Do you all understand? Do you all follow? So far good? Someone respond.
Yes.
Okay. Now you see I'm going to ping and show you the ping will not happen. Sometime back it was pinging, but now it won't ping. The reason is, even though they are in same network, In layer 2, they belong to two different logical switch. Okay, they belong to different logical switch. Let me go to the switch and show you that. Show MAC address table. You see, this belong to VLAN 20. Let me try pinging from here. Ping 10.0.0.2. It won't ping from here also. But I'm just provoking something so that I can see some MAC address learning here. You see, it says this is different MAC address. This belongs to VLAN 10. Okay. Let me try to show you both MAC address in the same place. Look at this. They belong to two different group. That's why they are not pinging. MAC tables learn MAC address dynamically, but they don't ping because they belong to two different broadcast domain. They don't ping. 100% loss on both. Okay, so we are not able to reach each other because they belong to different broadcast domain. Now let us assume another scenario. I have another switch and two computers and this one I would like to configure as 10.0.0.10 or 11, let me say 11, and this one I would like to configure as 10.0.0.12. We have not created any VLAN. After assigning IP address, they will be able to ping. Let me assign IP address. So I am repeating the same process so that you will understand better. 12. And this one this. Now if I ping, definitely it will be pinging. Wait, you go and check the MAC table now. Show MAC address table. You see there's one MAC address already there. Let us try pinging and then we'll check the MAC address. This time it is pinging. The reason is they are in same VLAN. You see, both are in same VLAN, the default VLAN. Show VLAN brief. They are in same VLAN. Let us create VLAN 10 and 20 here. I told you name is optional. I am not giving name. I named this as switch 2. For the VLANs I didn't give name. For the switch I have given name. That is helping us to identify. Now interface F01 switch port access VLAN 10. Interface F02 switch port access VLAN 20. show VLAN brief. You see? Oh, sorry. I put both in VLAN 10. I said 20, but I put 10. Let us change it. Okay, it overwrites. Let's verify. Show VLAN brief. You see that? Interface F01 is in VLAN 1. Interface F02 is in VLAN 2. 20. 10 and 20. Now, will these two ping? Can someone answer? Will these two ping? Will these two ping now when we have put those ports in different VLAN? Show MAC address table. It won't ping because they are in two different VLAN. It won't ping. This pinged because they were in same VLAN earlier, but now we have put in two different VLAN. It won't ping. Okay, so what can we do? You don't need to do anything. We want to learn VLAN, how it works. And you have seen that VLAN puts these ports into different virtual switch. That's why they are not pinging. Now let us assume that we want to make this A device and this B device to be in one group, and the C and D to be in another group. What I mean is these two should reach each other, ping each other. Even though they are in two different switch, I want these two to form one group. Let me draw one rectangle. These two I want to form one group. And the other two another group. For that, what we need to do is you need to connect one wire and make that wire as a trunk link. By making this port as a trunk port, by making these two ports by configuring this port as a trunk port, this link will function as a trunk link. This will become a trunk link. What is trunk link? Trunk. See, the elephant has got a trunk. Tree has got a trunk. An elephant the water, it sucks through the trunk. Breathing is also through the same trunk only. Take a tree trunk. Water is also sucked through the trunk to all the branches, leaves and fruits. Not only water, all the necessary minerals from the soil. So what is a trunk port? A port that can carry multiple VLAN traffic. Yeah. So when this guy pings, it will use the trunk port and talk to this guy. When this guy pings, it uses the same trunk link to talk to this guy. Can this talk to this? No. Because before sending, it will say the packet belonged to what VLAN it belonged to. So the receiving switch will not send to other VLANs. Let me show you that. After making this as a trunk port, you will be seeing that this and this will talk, and this will talk, because this is in VLAN 20, this is also in VLAN 20, whereas this one is in VLAN 10, this one is in VLAN 10. What do you understand from the story? Regardless of which switch they belong to, if they are in same VLAN, they form a group. Yeah. Now let me make these two ports as a trunk port on switch 1. I think this, I named it as switch A. Switch A. This is switch B. So on switch A, interface F03, switch port mode trunk. Such just one command makes this port as a trunk port which can carry multiple VLAN traffic. Same way on this switch B, switch port mode trunk. That's it. We have configured trunk on both sides, which means this link can carry VLAN 10 traffic as well as VLAN 20 traffic. So if I now ping from here to 10.0.0.2, I won't be able to ping because they are in two different VLAN. But if I ping from here to 10.0.0.11, it will ping because they are in same VLAN, though they are in two different physical switch. Physically they are in different switch, but logically they are in same VLAN. This one and this one pings because they belong to same VLAN. So let's try now. I'm going here to ping 10.0.0.11. It pings. Will I be able to ping 12? No. Not possible. Because 12 belong to another VLAN, VLAN 20. If you want to ping 12, you need to ping from here. Ping from here. 10.0.0.12. It pings. What do you understand? This port and this port formed a group via this trunk. This trunk is extending VLAN 10 as well as VLAN 20. Did you understand the meaning of trunk port? And do you understand how this works? The pinging? Now, actually when we have different VLAN, we will not have same network. See, even if you have same network, you will not be able to ping the other VLAN members. So better put them in different network. So I'm saying 10.1 network. So layer 3 also different network. See, this is 10.1, this is 10.0. Layer 3 also different network. Layer 2 means what? VLANs. That is also different. So in the real world, we will not put different VLANs in same network. We will put different network. That's how the real world works. This is 10.1. Okay. Now if I ping 10.1.0.11, I won't ping 10.1.0.2. I'll be able to ping. Hey, what is wrong here? Ping 10.1.0.2. Yeah, I'll be able to ping this too, and from here I'll be able to ping 10.0.0.1. Okay, so let me explain you one more time with my writings. when you ping from here, what VLAN this port belong to, you know? VLAN 10. This VLAN 10. This VLAN 20. VLAN 20. This one is trunk. It carries both VLAN 10 and VLAN 20. Now, when you ping from here, 10.00.11, before sending the packet out, it will put VLAN number, so that this switch, when it receives, it knows that the packet belongs to VLAN 10, not VLAN 20. And when you ping from this PC, you're saying ping 10.10.12. The packet, when it is sent out on the trunk link, it will be sent with VLAN 20. So the receiving switch will know that the packet belongs to VLAN 20. It will only send here, not to the other port. So you can have many VLAN 20 members and many VLAN 10 members. Yeah. Do you all understand VLAN?
Yes, sir.
Okay. Other than trunk port, it is a good practice to make these ports as access port. Access port meaning they carry only one VLAN traffic. They belong to only one VLAN. Switch port mode access, meaning they are not trunk. Interface F02 is also access because they are that is also VLAN 20. VLAN 20, this VLAN 10. All the access ports will be member of single VLAN. What about trunk port? It will carry all VLAN traffic. So F01 and F02 we can configure as access. Done. That's all. Alright, we have finished VLAN topic.